in this section, we're going to deal with the integration of rational functions by the method of partial fractions and the computer algebra system. Okay. Yeah. Okay. It is not obvious how to evaluate the integrals of complicated rational functions like this. So, the integrals of complex rational functions. Rational functions can be written as f of x is equal to p of x over q of x, where p of x and q of x are polynomials. Okay. For example, the antiderivative of this function, this integral, is in the correct form to proceed with the partial fraction decomposition, like this. Okay, these rational functions can be written as this, where s and r's are both polynomials, but degree of r of x is less than or equal to the degree of q of x. Okay, that can be done by the Chinese remainders theorem. Okay, here. For example, if we have to evaluate x cubed plus 1 over x plus 2 with respect to x, then we divide the denominator with the numerator by denominator. Okay, then this x cubed plus 1 can be written as x squared minus 2x plus 4 minus 7 over x plus 2, like this. Then integration of this this rational function is much simpler in this way, because the integral of x squared is x cubed over 3, and integration of minus 2x is just minus x squared, and integration of 4 is just 4x, and all we have to worry about is these rational functions, which we already know. It is the antiderivative of this function, this rational function, is a log function. So we can easily get the integration of this rational function after the partial fraction, like this. Okay. So in general, there are several cases. First case, the denominator q of x is a product of distinct linear factors, like this. Okay. Right. Then, where no factors is repeated. Okay. In this case, this rational function r of x over q of x then we know there exists the constant ai is such that r of x over q of x is equal to this right hand side. So after solving this equality, then we can get ai's when these terms has no factor repeated. For example, if we have these rational functions, then we can factor this numerator. Okay, here the denominator can be factored as x plus 1 times x minus 2 times 3x minus 1, like this. And there is no repeated factor here. So these methods can be adopted here. So let's set it like this, equation 3, then solve this linear system of equation like this to get a is equal to minus 1/2, and b is equal to 2/5, and c is equal to 13 over 15. Then this integration of rational functions can be written in this way. As you see, this the antiderivative of this first term is a log function, and second one also, and third one also. So you can easily have the integral, have the indefinite integral of these rational functions. As you here, as a cos command was given, and this integral can be written here, and if you do use expand the partial fraction of the above, then you will have this partial fraction without much difficulty. And if you do find the integral of this function with respect to x, then we have the answer like this, which is same with that. So, yeah, now we have a tool to have a partial fraction, and also we have a tool to get the integral of these rational functions. Okay, there are alternative ways to get those coefficients. The next problem here. If we do want to find the indefinite integral of this, then the method of partial fractions can be used here to solve it. Then here we have a is equal to 1 over a plus b, b is equal to 1 over minus 1 over a plus b. So the integral of this one can be easily obtained by the simple integration, which is related to the log function. Okay, if we try it in Sage, then for this is the function that we had. Then we expand the partial fraction and to find the integral of it. Better do it in here. As you see, we have the solution that we have here, exactly same as this one. So if we use the same command with which it can be done with the technique which was introduced, then you can always deal with such integration. Okay, there's other problems, and also this expression can be simplified in this way as well. Okay, by using the property of logarithm. Case 2. If Q of x is a product of linear factors, some of which are repeated, like this. Like this. Then instead of a single term in the equation 2, okay, so in this case, it can be the given rational function can be written in this way. Then after we solving that equation, we're gonna have AIs. Here is an example of such case. Here we have what? We have the repeated factor like this. Then for this repeated factor, this can be written as a over x plus 1 plus b over x plus 1 square plus c over x minus 2, which has a linear factor like this. If you solve it, you're going to have a linear system of equation like this. Then you can have A, B, C's like this. Then the given rational function can be written in this way. So you can use the earlier knowledge on the integration of this function and this function and this function. The first one was a logarithm, and the second one was just rational function like this, and third one is a log function. So it can be simplified in this way, which can be also found by the computer algebra system which we introduced. So case 3, if Q of x contains irreducible quadratic factors, none of which is repeated. Okay, if we cannot find the factor of this denominator, then we should use a completing square, 완전 제곱식, completing square, to have a form like this. Then use this type of the integration. Because we know the antiderivative of 1 over x squared plus a squared is this. Okay. For example, in integral 1 over x to the fourth minus 1 dx, here we have this can be factored like this, but cannot be factored any further. So this can be factored in this way, and in this case, if you have x squared plus 1, then you should have a linear term, cx plus dx, cx plus d as a numerator to solve it, which gives us a, b, c, d like this. So the given equation can be simplified in this way, and that logarithm and logarithm and arctangent here like this. So, but whole this process can be simplified in CAS with the same command that we introduced. Example 6, for this integration, this can be factored like this. Then here you have a linear term, and here you have a quadratic form. Then the numerator should be bx plus c. Then you solve the linear system of equation, which gives us a, b, and c as 1/2, -1, and -1/2. So this one can be written as this, which gives us a logarithm and a logarithm. And this can be done by completing square. 이걸 완전 제곱식으로 고쳐놓고 치환해서 이제 구해준 거예요. Okay? But this also can be done in here. Copy, and if we check it at the single cell, then this is the given function in the example 5 and section 7.2. Then this is the integral, and these are the partial fraction. This is a partial fraction. Okay, you see, the given one can be partial fractions like this, and the integral value is like this, which you have seen in here. Okay. All right. And case 4, when Q of x contains a repeated irreducible quadratic factors like this, where b squared minus 4ac is less than 0. Then this should be written in this way to be partially factored. For example, if you have this function like this, then this can be factored like, it should be set like this to have a partial fraction of the given function. Okay, like this, cube force like this, because this has linear term and force term. Then what you have is a linear term. For the force term, you not only have one, you should have the 4 terms to be solved like this. That's the technique. But that also, if you use the CAS command, then you don't have to worry about the things, because partial fraction can be easily obtained with the same command that you have seen before. For this problem, as you see, we should have this type of the technique for the partial fraction, because it's a quadratic form. You should have 2 terms for that. But in here, the one interesting thing is, if you go through it, then you will have the repeated one here to go back to it to get what you like to have, which is I. So, but the same thing can be done with the same command for partial fraction and the integrals. So, actually, for the most of case, you can use the same technique if you understand what is going on. Okay, So yeah, for different cases, you may choose which way you like to apply. But in general, if you use this partial fraction command, then you will have the partial fraction without much difficulty. So if the task program does give you the solution in a way, then you may simplify the given function with such a command like this expand partial fractions to simplify the given function to get the integral that you like to have. Also, there is a substitution techniques. For functions like this, then you need to substitute it to make a simple form like this. For this way, if you substitute this square root part as t, then x can be written in this way. So dx can be found in this way. If you resubstitute it, then this can be written as a function of t like this, which partial fraction technique can be used. And integration formula, simple integration formula can be used as well to get the answer like this. But with this same command that you have learned, the answers can be obtained as well. Evaluate the integral of this partial fraction can be used, but with this, you can solve it with the sage command like this. Okay. And also, we have developed the sage graph for integral. I may show you what it is. Okay. Copy. Link, copy. And go. Okay. This shows the original function and its integral. For example, if a moves, then this f of x is given, and integral f of x is given here like this. If you move, change b's, then for this function, 6 times sine 9x, the integration from minus 50 to 50 f of x is like this. If you move this one to c like this, then so if you change this interval, canvas size little bigger, and as you see, for this function, the integral of this one can be obtained like this. So actually, this cell, you can find the integral of this type of the function without doing nothing. And also, so just we tried to show the given function and its integral of it with the interval that we can set with the different coefficient and the conditions. Okay, anyway, that's what we have done. Okay, there are plenty of the examples, the exercise problems to deal with. So you may try some of those with the hand or the CAS tools that I have supplied to you to get. Okay, any questions for section 6.4?